Today, we're talking about compound probability and understanding when we have independent events and dependent events, okay? And we want to be able to calculate those probabilities, and it's actually really quite a simple thing to understand. And so what I have here is a little cup. It's got some dice in it, and you can see there's all the different kinds of dice that are in there. There are 5 green dice, there are 4 red dice, there's 3 whites, 2 yellows, and 1 purple die. Okay? How many dice are there in all? 15. Yeah, there's a 5, 4 and 1 makes 5, and 3 and 2 makes 5, so that's a total of 15. All right, very good. So now, let's say I've got all the dice in my cup. What is the probability that I pull out a red one? 4 out of 15, right? Oh, I lost. Okay. So I can, that's pretty easy to calculate. We knew that there were 4 reds, so that's 4 winners out of 15 possibilities, right? And so I put it back in the cup now. What's the probability that I pull out a red? 4. Still 4 out of 15, right? Oh, I got a winner. Magical. Okay. Now, did I put it back in the cup? Okay. So what happened with the cup? There's 1 less. There's no longer 15 die in there. And there's 1 less red, right? Okay, so now what's the probability of me pulling out a red? 3 out of 14. Very good, ladies and gentlemen. Do you think that that was an independent event or a dependent event? Dependent, yeah. So what happened was my initial pull was I had 4 reds out of 15 die. When I put it back in the cup, my cup is now filled the same exact way as it was the first time, right? Now, if I do it again, I have that same starting amount, same starting reds. It's an independent event because everything stayed the same. But when I remove that red winner, now I've changed what's in the cup. And that new probability is dependent on what I had to remove. Okay? And this is the difference between independent events and dependent events. Is what we're starting with the same, then it's independent. If things have changed in the cup, then it's dependent, all right? So it's really easy to think about. And so that's what I love about probability is when it's just so easy. Okay, so here we go. Compound events are the probability of 2 or more simple events, like what I just did. 2 or more simple events happening. Independent events, the outcome of one event does not affect the outcome of the other event, and all we have to do to find the probability of 2 independent events is multiply their probabilities. That's all we have to do. We have a couple of things happening. We just have to multiply them together, which is really kind of nice. What is the probability of rolling a standard die twice and getting an even number, then a 5? So I'm going to write that down in shorthand. I'm going to use the probability we want of getting an even number, then comma, getting a 5. So this is what we're trying to look for. What's the probability of an even number and a 5? So think about my standard die here. What's the probability of getting an even number? 3 out of 6. There's 3 even numbers, 2, 4, and 6. So there's 3 winners out of 6 different sides there. And what's the probability of landing on a 5? 1 out of 6. Those are all independent events because I'm going to roll that dice and it starts with the same 6 sides every single time. Nothing changes there. How do you multiply fractions? Straight across. Multiplying is so easy, ladies and gentlemen. 3 times 1 is 3. 6 times 6 is 36, and that reduces to 1/12. We can divide top and bottom by 3, and we would get 1/12, okay? Number 2, what's the probability? So I'm going to use my simple notation here, P for probability. What's the probability of tossing a coin 3 times? Well, let's see, and getting a tails each time. So probability of tails, comma, tails, comma, tails. That is what we want to know. Tails, tails, tails. So, again, I'm flipping a coin. What are our options when I flip a coin? It's just heads and tails, all right? How many winners would there be? 1. One winner, the tails would be a winner out of 2 options there. And then for the middle one, I'm going to flip the same coin again. What's the probability of getting a tails? 1 out of 2. Again, a winner out of 2 options. And then the third, again, is a winner out of 2 options. And so what is that probability? 1 out of 2 times 2 is 8. Oh, there it is. Okay. So 1 out of 8. So those are all independent events. Here's some more examples. Each spinner to the left here is spun once. So we have 2 different spinners. You can see here we've got a spinner numbered 1 through 12. There's some shaded zones. Here we have some colors. Oh, look at that. There's a couple of reds and a couple of greens there. All right. Each spinner is spun once. Would these be independent or dependent events? Independent. One spinner does not affect the other spinner. They're completely independent events. What's the probability on the first spinner that we get an 11? 1 out of 12. There are 12 regions, and 11 is one of those. So 1 out of 12 times getting a red here. What's the probability of landing in a red zone? 2 out of 5. 1, 2, 3, 4, 5 zones, and red takes up 2 of those 5. All right, multiply straight across. What do we get? 2 over 60. 5 times 12 is 60, and that reduces to 1 out of 30. All right. Number B. What's the probability we land in an unshaded zone? 8. There are 1, 2, 3, 4, 5, 6, 7, 8 unshaded zones out of 12 possibilities. And what's the probability we land in a green? 2 out of 5. 2 green zones, 1, 2 out of 5 possibilities. Multiplying straight across, 8 times 2 is 16. 5 times 12 is 60. And I think I can divide those by 4. Divide by 4, top and bottom, I get 4 out of 15. 60 divided by 4 is 15. Probability of at least a 3. What does that mean to be at least 3? Almost. 3 or more, which is a fine distinction there. At least 3, when I read that, I translate it to at the lowest, it's 3. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all of those would be at least 3. So at the lowest, it's 3. How many regions are at least 3? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are at least 3 out of 12 possible regions. And then landing blue? 1 out of 5. Straight across would be 10 over 60, which reduces to 1/6. That's an easy one. The zeros just cancel out, right? Well, it's really dividing by 10. All right. This is an interesting one, and I want to talk about it because of the word and. So we want to know the probability we land on an even number and it's shaded. And is a very interesting math word. It must be both of them, okay? So how many numbers are even and shaded? Which numbers are even and shaded? 2 is even and shaded, and 8 is even and shaded. So it has to be both of them when we use the word and. And so how many winners are there? 2. Very good. Out of 12 possibilities. Then not red. How many not reds are there? 3. There's a green, and a blue. So that'd be 3 winners out of 5. And when we multiply straight across, that's going to be 6 out of 60, which of course I can divide top and bottom by 6. So I'm going to get 1 out of 10. Okay, any questions on those? Okay, so compound events, that just means that there's more than one event. These were all independent. Let's turn the page. Let's go down to do number 6. So we have 5 red marbles. 1, 2, 3, 4, 5 red marbles. 1 orange, 2 green, and 4 purple. So I just like to draw it out so I can kind of see that are all in a bag. And a marble is drawn out and then replaced, and that's an important word. We're putting it back. And then another marble is drawn. So if I take my marble out and I look at it and put it back in and draw again, is that independent or dependent? Independent, because I'm starting with the same stuff in the bag every time. How many things are in the bag? 12. 12 items are in the bag. Very good. What's the probability of getting an orange? 1 out of 12. What's the probability of a purple? 4 out of 12. That is 4 over 144, which reduces, divides by 4, we would get 1 out of 36. All right. What's the probability of getting both orange? Can't talk today. What is the probability of getting an orange first? 1 out of 12, and then you draw 1 out of 12, you put it back in. Now what's the probability of drawing an orange again? 1 out of 12. And that is 1 out of 144 tries. You might get it once. Pretty crazy. All right. So those are, again, independent events. Let's talk about dependent events. In dependent events, the outcome of one event affects the outcome of the other. As I said before, what's starting in your cup or starting in the bag of marbles changes. All right? It's no longer the same as what we started with. But the idea is the same. We are still multiplying their probabilities. There's no difference here except your thinking, and that's all you have to do is just think a little bit. So on number 7, there are 3 green markers, so I'm going to draw green, green, green. There are 6 yellow markers. There are 4 red markers, and there are 12 blue markers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. In a box, a marker is drawn, then not replaced. So we're not putting it back in. And then another marker is drawn, and we want to find the probability. So it's nice to have a little example here. How many items are in our pencil box? 25? 25 to start, so there's 25 items altogether in that pencil box. What's the probability we draw a red one? 4 winners out of 25. Now, I drew one of those markers. I don't know what color it was, but I drew one of them away. Then what's the probability that, so let's pretend I got a red. If I got that red, what's the probability that I then draw a blue? Yep, there's still 12 blues in there out of how many markers are in there now? 24. And that's the difference because we pulled out one of our winners there. All right, I don't know what that is. I have to use my calculator. 4 times 12 is 48, and 25 times 24 is 600. Thank you. And then how do you do this in your calculator? Because that's just a little bit big. 48 divided by 600. What do you do to reduce that? Math bracket. Math bracket. We get 2 out of 25. Oh, my nose itches today. All right. So I'm going to put my marbles back now. I'm restarting with full marbles. So what's the probability I draw a yellow marble?
6 out of 25.
Yeah, 6. There's 6 yellows out of 25. Let's say I draw one of them. I got one. I don't put it back. Now what's the probability I draw a green one? 3 out of 24. There are 3 greens, but only 24 marbles in there now. That turns out to be 18 over 600. And if you math frac that, you're going to divide by, that's easy to do actually. Divide by 6, we get 3 out of 100. All right, I'm putting my marble back. So I have a full set, what we started with once again. Now, what's the probability I get a blue followed by a blue? What's the probability I draw one blue? 12 out of 25. So I've got 12 blues here. Oh, I got one. Now I take it away. I don't put it back in. And I already got one of them. So now there's only 11 blues from which to choose. And how many are in my bag now? 24. So that is a good example of how the probability is changed. 11 times 12 is 132 over 600. And that reduces to 11 out of 50. All right, now I'm putting my blue marble back in there. Got a full bag once again. What's the probability I get a yellow followed by a yellow? What's the probability of drawing a yellow? 6 out of 25. So, I got one. So one of my yellows is gone. Now, what's the probability of getting a yellow again? 5 out of 24. Very good. That's 30 out of 600. And I can divide each of those by 30. What is that, 1 out of 20? Yeah, look at that. All right. Do you have questions on this? Are you finding this pretty easy? Hey, that's what I go for. Then I think I'm going to leave it at that. We will stop right there. Pretty good.